Hi friends, this is Gautam. So today's session we are going to discuss about a label distribution protocol. So in MPLS layer 3 VPN series, so today's session we can discuss about LDP protocol. So if anyone watching this video first time means please refer the previous concepts, then only you can understand the LDP protocol. So in that video description itself I mentioned the link, so you can follow that link so you can able to understand. Okay, so this is the example scenario, so we can use it for a full entire series. So this rectangular box, in the rectangular box 5 routers are there. These are the service provider routers. So in last session we are implementing the MPLS. So while we are implementing the MPLS, once I configure MPLS, automatically LDP protocol is enabled. So that time I told you how that LDP will be formed. So LDP will be formed in backend process. So today's session we are going to discuss about how the LDP will be formed, how the label will be exchanging between one router to another router we can discuss. So let's go to the R1 router. So in R1 router I just tried to ping the R5 router loopback IP. So R5 router loopback IP is 5.5.5.5. So just go to R1 router and type 5.5.5.5 enter. So I am getting ping. Next I am going to trace route 5.5.5.5 whether I can able to reach the R5 router loopback through MPLS or normal IP version 4 enter. So here we can see through the MPLS I can reach the R5 router 5.5.5. Okay, so let's go to the topology. So in the topology R1 to R2 I just right click and capture the Wireshark. So then I will disable the MPLS in R1 router, then again I will enable the MPLS. So automatically LDP protocol will be formed. So in backend process what are the things are going, so everything will be captured in the Wireshark, then we can analyze it. So just go to the R1 router, give no MPLS. So before that I have to give do show MPLS LDP binding for 5.5.5.5/32. So in MPLS LDP binding the local label assigned as 107 and remote router assigned as a 207, and as well as I have to check do show forwarding table. Do show forwarding table 5.5.5.5/32. So MPLS forwarding table 5.5.5.5/32. Okay, so local label is 107 and outgoing label is 207. So show MPLS LDP binding, like all the possible labels should be there, and forwarding table is a best path. So based upon that the packet will be forwarding. Okay, so now just go to the global mode and I will give no MPLS space IP. Now MPLS is disabled in R1 router. We can see the LDP neighbor is down. Okay, again I am going to enable the MPLS space IP enter. Okay, now the MPLS is came, just a single command I will remove it, the MPLS will goes down, and again I will enable that command, MPLS will come up. So just stop capturing the Wireshark between R1 and R2. Okay, so the Wireshark file is here. Okay, so before that in MPLS, so the label should be assigned to the each and every indirect connected network. So that is not fixed. For an example, R5 router loopback 5.5.5, R1 router will assign the label as 107 before disabling the MPLS from R1 router. Now again I will enable the MPLS. We can see the label should be changed. So in this scenario each and every router I will assign as label. For an example, R1 means the PE1 means 100 to 199, and R2 means 200 to 299, R3 means 300 to 399, R4 means 400 to 499, and R5 means 500 to 599. So why I am assigning label range means for understanding purpose I will assign, because the label is locally significant. Each and every router the label assigning starting from 16. So if I am not giving this range means it's difficult to understand. For that purpose, for studying purpose, I will configure manually. But in production network, no need to configure the MPLS label range, because each and every time the interface goes down and come up means the label will be changing. The router will be rebooted also, the label will be changing. So if you are giving any particular range means it will be creating an issue in production network. Okay friends, let's go to the Wireshark and we have to analyze the what we have to capture. Okay, so these are the all the protocols. What are the protocols running on that router? Everything will be captured. For an example, OSPF, this loop. So we can avoid this one. Just focus on LDP protocol. So LDP. So in LDP protocol, label distribution protocol will send the allow message. For an example, just go to the first packet. R1, okay, this is 10.10.10.1. So 10.10.1 is an PE1 interface gig 2/0 interface. We assign 10.10.1. That means R1 router will sending the allow packet, that is an UDP packet. Allow packet, that is LDP packet, LDP allow packet is sending. So that is UDP protocol. So they can use the source port number as 646 and destination port number as in 646. So 646 is a well-known port number and is a well-known port number for LDP. LDP is a label distribution protocol. Okay, source IP is R1 router physical interface IP, that is 10.10.10.1, and destination IP is 224.0.0.2, that is a multicast address for LDP, and source MAC address is R1 physical interface, that is gig 2/0. So we have to configure manually 111, and destination MAC address is multicast MAC address. So 01005 is a multicast MAC address, and last 23 bits of multicast IP is converted into hexadecimal. That's why we will get 000002. Okay, so the LDP allow packet is an UDP protocol. Okay, so in that UDP label distribution protocol is there. So in that label distribution there should be an LSR ID. So I already told you in MPLS LSR is a label switch route ID. So in OSPF, if one router we want to point out, we have to point out that particular router means through the router ID only we can call it. So route ID means is name of that router. So same like in MPLS, LSR ID means, so if you want to point out one particular router in MPLS means through the LSR ID only we can point out. So first preference gives to the loopback interface. So which one is an highest one, it will take it. If there is no loopback, then physical interface. In physical interface, which IP is an highest IP, it will take it. So in R1 router we already configure loopback. So here we can see PE1, that is R1 router, we already configure loopback as a 1.1.1. So that's why it's sending the LSR ID as 1.1.1. So in that label distribution protocol, the allow message should be there. In that allow message, there should be a transport address should be there. So the transport address, IP version for transport address. So this transport address is 1.1.1. By default, LSR ID equal to transport address. That means LSR ID equal to 1.1.1 means transport address also 1.1.1 by default. If you want, you can change the transport address differently. Okay, so this is the allow packet of R1 LDP allow packet. So next to one R2 allow packet. So R2 LDP allow packet. So R2 router 10.10.10.2 is a R2 connecting towards the R1 physical interface IP. That is a source IP and destination IP is 224.0.0.2. So this is the R2 router physical interface MAC address and destination should be a multicast MAC address. So this is an label distribution protocol. So this is a UDP protocol. LDP is an LDP allow packet is an UDP and use the source port number as 646 and destination port number as an 646. So 646 is a well-known port number for LDP protocol. So in that label distribution protocol, they have LSR ID. So LSR ID is R2 router have loopback IP. So that is 2.2.2.2. Next to one, in that allow message, they have an IP version for transport address. So the IP version for transport address is 2.2.2.2. So normally LSR ID equal to transport address. So LSR ID is 2.2.2.2. Transport address also 2.2.2.2. Okay, so first of all, both routers will send the LDP allow packet, that is an UDP packet, and source port number and destination port number is an 646. So in that allow packet, they will send the LSR ID plus transport address. Once both router can learn the transport address, then through the transport address only they will exchange the label. So we can see. So before exchanging, they can use the three-way handshake. For an example, this is an hello packet. So this all should be an hello packet. So here we can see. Okay, so through the allow packet, the transport address will learn from R1 router as well as R2 router. So R1 transport address is 1.1.1.1 and R2 transport address is 2.2.2.2 because LSR ID equal to transport address. So here we can see. So through the transport address, they will do the three-way handshake. So after completing the three-way handshake only, so here we can see. So first packet, so through the transport address, they will do the three-way handshake. So the three-way handshake is, so here we can see 2.2.2 is an R2 router. So R1 router transport address is 1.1.1 and R2 router transport address is on 2.2.2.2. So which one is an highest IP? R2 is an highest IP. So R2 is an active LDP and R1 is an passive LDP. So R2 router will initiate the three-way handshake. So R2 router will initiating the three-way handshake. So in the three-way handshake, which one is the active LDP? They have the highest port number. So here you can see highest port number is 31681 and destination port number is a well-known port number 646. So R2 router is the highest transport address. So this is the active LDP. They will do the three-way handshake. So they will send the acknowledgement three-way handshake. Then R1 router. So come here. So just we can filter it. It will be easy to show it to you. Or select next one. So LDP. Okay. So now LDP protocol only I selected. So let's come below. So these are all the hello packets. So here we can see LDP protocol only there. So 2.2.2 1.1.1. So through the LDP hello packet, so the transport address should be there. So which one is an highest IP? That should be an active LDP, and which one is the least one? That is a passive LDP. So active LDP will initiate the three-way handshake. So here we can see the three-way handshake. So R2 is sending the keep alive message, R1 signal acknowledge it, and R2 is replying to that one. So three-way handshake is going on there. So here we can see three-way handshake. First R2 initiate, next R2 replying, then signal acknowledge, and finally it's completed. Okay, so after completing this three-way handshake, then only they are going to distribute the label. Here we can see R2 router first send the what are the label R2 router will locally assign, will distribute to the R1 router. So here we can see these are the three-way handshake. After completing R2 router 2.2.2, I just click this packet. So just maximize it. R2 source IP should be in 2.2.2 and destination IP should be in 1.1.1. And source port number, so active LDP only first distributing is labeled to R1 router, so that's why source port number is highest port number and destination port number is in 646. Okay, just come below. So these are the label distribution protocol. So LSR ID is there. So next one, label mapping message. So in that label mapping message, FC element. So FC element, here we can see 1.1.1. So that means in R2 router 1.1.1 they will assign as this label. So generic label is they given in hexadecimal. So just now just we can focus on 5.5.5 R5 router loopback interface only we can focus here. For an example, I will take it one network. So let's go to that one 5.5.5. So this is a 3.3.3. So 4.4.4.4. Okay, this is a 5.5.5 network. So that is in label distribution. That means, so in this packet, address message label mapping message. So once through the transport address only, the three-way handshake will be happen. So in the transport address, which one is an highest IP? That is an active LDP, and lowest IP should be an passive LDP. So the active LDP will initiate the three-way handshake. Once the three-way handshake is completed, the active LDP send the label first. So that's this packet is the first packet R2 router is sending. So in that packet we can focusing on 5.5.5 network. So just right click. Okay, just focusing on 5.5.5. So generic label. So here we can see the label they given as an hexadecimal. So here we can see 1100111. So first last 8 bit you can take it. So just I open notepad. So what they given 1100 space 1111. So this is a binary format and they converted into hexadecimal. So in that binary format, this is an 8-bit binary. So 8-bit binary is, this is 1 2 4 8 16 32 64 128. So now we can add that value. So 128 64 32 16 8 4 2 1. So now 128 is 1, so we can add 128 plus 1 is 64. 128 plus 64 is 192. Next one 32 0 16 0, no need to add. Next one 8. So 192 plus 8 is 200. Then 4 is there, 1 for 4, so 200 204. Next 2 also 1, you can add that value 206, and 1 also there, so you can add this value. So totally 207. So for 5.5.5 R2 router will assign the label as 207. So once again I will repeat. So in prefix 5.5.5 they assign the generic label. So this is given in binary format and this is in hexadecimal. So just I'll take it that binary format 1100111. So 8-bit binary representation is 128 64 32 16 8 4 2 1. So if you are adding this value, so what are the binary bits is 1, you can add the corresponding decimal value. So 128 64 you can add, 32 16 0, no need to add. Next 8 4 2 1 is 1, so you can add 8 4 2 1. So 128 plus 64 192 plus 8 200 204 206 207. So R2 router will assign the label for 5.5.5. R5 router loopback is 207. Okay, so likewise each and every router they are sending the labels. So just for example I will take it one network. Next we can go to the R1 router, that is a passive LDP. So I just click that packet, just maximize it and come here. We have to check it for R5 router. So here we can see R5 router, R1 router will assign as. So just open the notepad file. So the given decimal binary format. So here we can see 5.5.5 they given 011 0110 1100. Okay, so again 128 64 32 16 8 4 2 1. Okay, so now 128 is 0, no need to add it. 64 32 11 96 and 16 is a 0, 8 is 1, 4 is 1. So now we can add 64 plus 32 96, 96 plus 8 104, 104 plus 4 108. So R1 router will assign the label for 5.5.5 is 108. Okay friends, we can go to the R1 router. We can see. So just give show MPLS forwarding table for 5.5.5.5 space 32. So R1 router they will assign the label as for 5.5.5 is 108 and R2 router they will assign 5.5.5 network as 207. Okay, just give enter. Here we can see local label R1 router will assign as an 108. So what we can find out 108, correct. Next one outgoing label is 207. That is R2 router will assign 5.5.5 network is 207. So we can learn this 207 from R2 router. So same like we can go to the R2 router and check it. Show MPLS LDP binding for 5.5.5.5 space 32, enter. So local binding is 207 and R1 router is assigned as an 108. Okay, so through the LDP protocol, so just we are configuring MPLS. So within a fraction of seconds the LDP protocol is enabled, but in backend first of all it will send the R1 router LDP allow packet with the source IP of physical interface IP and destination IP is multicast address 224.0.0.2 and layer 4 information port number is 646. Source and destination port number is 646 is a well-known port number for LDP. Next in that LDP allow packet there should be an LSR ID. Then in that LSR ID we have the transport address. So by default LSR ID equal to transport address. So LSR ID is 1.1.1, transport address also 1.1.1. Next one R2 router also sending the allow packet with the interface with the source IP of physical interface and destination IP is a multicast MAC address 224.0.0.2 and source and destination port number is a well-known port number 646 and in that LDP packet LSR ID is the 2.2.2.2. So by default LSR ID equal to transport address. So here 2.2.2. So once through the LDP allow packet is an UDP packet. Okay, through the LDP allow packet they will learn the transport address, which transport address is an highest one that act as an active LDP, least one is an passive LDP. Once they learn the transport address, then they will do the three-way handshake, that is an TCP. After completing the three-way handshake, the active LDP will distribute the label to the passive LDP. So same like passive LDP will sending the label back to the R1 router. So now the label will be exchanging. So within a fraction of a second the LDP will be formed, but backend this much of process is going on. Okay, so and also we can check it here, show MPLS LDP neighbor. So if you are giving this command, we can check it who are all the LDP. So what are the things, I will show it in the Wireshark. We can see it here also. So 2.2.2 is an active LDP. We can see the port number as an highest port number is 30157, and LDP, passive LDP, is an least IP, that is in transport address 1.1.1, and well-known port number is in 646. So here we can see source IP address. Normally the LDP allow packet will be coming from the source interface IP 10.10.10.2. So what are the networks R2 router having? 10.10.10.2, 20.20.20.1 and 2.2.2. Here we can see R2 router loopback 2.2.2, 10.10.10.2 and 20.20.20.1. So same like in R1 router also we can see, so R2 router show MPLS LDP neighbor. So this is for R3. So just focus on R1. So R1 transport address is 1.1.1 and R2 transport address 2.2.2. So R1 is an passive LDP, well-known port number 646. So this is an active LDP with the highest port number. So source IP interface, that means the source LDP allow packet source interface is 10.10.10.1. So from the physical interface only we are getting the allow packet source IP. So what are the networks R1 router have? 10.10.10.1 and 1.1.1. So we can see 1.1.1 and 10.10.1. So same like each and every router, once you enable MPLS, the LDP will be forming. So just for understanding purpose, just understanding the concept, I will take it as an R1 to R2. So same like it will happening R2 to R3, R3 to R4 and R4 to R5. So each and every point to point network, if you are configuring MPLS, the LDP will be forming and the same process will be happen. So how the label distribution, the allow packet will be sending in the allow packet transport address, through the transport address they do the three-way handshake. Next one, active LDP will initiate the three-way handshake and they will distribute his label, then passive LDP will distribute his label. So likewise it will be happen. Okay friends, so this video is very useful to you, I think. So if you are like this video, means please subscribe and share to your friends also. Thank you friends.